Good morning, everybody.
Good morning, sir.
Good morning. Yes,
Sure. If sir permits, then we can start. It's all to Sir Arun sir that if he feel, then he may start.
so Farhan Akhtar is going to start what?
He is anchoring the entire session.
Okay. So now I am going to start.
Sure, sir. It's
So
all yours.
before starting, I would like to share with you PPT. Thank you, Farhan Akhtar. Thank you very much. So, are you able to see slides? Is it visible?
Yes, sir, it is visible.
Okay. So, before starting univariate analysis and bivariate analysis, I would like to explain something basic. So, first of all, what will you do before doing analysis? Collect the data. So there are various techniques of collecting the data. You already have the idea about the types of data, primary data and secondary data. So now I am talking about only primary data. How to collect the primary data? So there are certain instruments you might be knowing. First one is questionnaire and second one is schedules. So through which you can collect primary data. After collecting the data, what will you do? So after collecting the data, you have to edit the data. So what is the need of addition? Addition is required to check the consistency, to correctness of the data, completeness of the data, as well as homogeneity of the data or homogeneity of the data, you can say. So what is the meaning of consistency of the data? Any one of you please tell me what is the meaning of consistency of the data? Hello.
Sir, if the data is reliable and it has almost the same values.
Reliability and consistency. These are the two different terms.
Sir, then if the data is giving almost the same values after being, if a respondent is being surveyed more than one time and then also he's giving the same response.
Same answer. Okay. So answer should be same after testing and pre-testing. So you might be knowing about the testing and pre-testing. After that, what is the meaning of completeness? If you have answers of all the questions, what you set in questionnaire, that is called completeness of the data, what you get from the questionnaire. And after that, next one, what is the meaning of homogeneity of the data? You might be knowing about the correctness of the data. Data should be correct if you know the answers, probable answers of all the questions, what you set in your questionnaire. So what is the homogeneity? Actually, homogeneity is the understanding of the questionnaire across the respondents should be uniform. It should not be different. So understanding should be uniform. This is the meaning of homogeneity of the data. So this is the basic aim of editing the data. After editing the data, what will you do? You have to classify the data on the basis of certain methods. Those methods are exclusive method or as well as inclusive method. All of you know about these two methods, so I'm not going to explain this one. And after classification, next one is presentation of data. Nowadays, presentation of data is also included in univariate analysis, but that is not the part of the univariate analysis. But most of the researchers may utilize this as a part of the univariate analysis, and data can be shown with the help of bar diagrams, pie chart, histograms, polygons, okay, divided bar diagrams or deviated diagrams, multiple bar diagrams, cartograms, etc., through which you can represent the data. Okay. After the representation of data, next thing comes how will you analyze collected data. So here we are talking about the univariate analysis as well as bivariate analysis through which you can analyze the data. Why do we call univariate analysis? Because here variable we are going to consider as a one variable. Suppose you have taken data on the basis of weight of an individual or height of the individual. So this is the single data, and you can analyze by the help of univariate analysis. So there are certain techniques through which you can analyze the univariate analysis, and those techniques are: number one, measures of central tendency, measures of variation or dispersions, and measures of skewness, kurtosis. Movement also sometimes gives you idea about the peculiarities of the data what you collected from the population. So what is the meaning of central tendency? All of you might be knowing about the central tendency, measures of central tendencies. This is very simple to explain, but all of you might have studied this one, central tendency. So what is the meaning of central tendency? Any one of you, please? You don't have any idea? Are you able to listen me? So Trijit, hello.
Sir, central tendency is mean median mode of a distribution.
Mean median mode. Who are you, madam? Are you a student? Are you a faculty member or a researcher?
Sir, a researcher.
Researcher. From which university, which college, or from BIT itself?
No, sir, from HNB Garhwal University, Uttarakhand.
Okay. Very good. Actual measures of, I'm asking about the measures of central tendency. So there are various measures of central tendency, like arithmetic mean. You are correct. Arithmetic mean, median, mode, symmetrical mean, as well as harmonic mean. These comes under, these come under central tendency. What about the variation? So under variation, we generally study mean deviation as well as standard deviation. So basically, arithmetic mean and standard deviation, these are the two measures which are very important for analyzing the univariate analysis. Other, suppose if you want to know the skewness and kurtosis, this is related to symmetry of the data, whether data is symmetrical or asymmetrical or skewed, positively skewed, negatively skewed, etc., etc. While understanding the central tendency, what will you do? First of all, you have to find out the single value. So this single value will give you entire characteristics of the data, what you collected from target population, or you can say from normal population. Actually, average lies in between two extreme values. Sometimes it is also, so this is the reason why we call this one as a measure of central tendency. Are you getting my point? So an average is single value, which is used to represent all the values in data set or series. Since the average lies in between the two extremes, it is sometimes called as a measure of central tendency. Now, question arises, why do we call measure of mean is also a measure of central tendency? Measure of mode is also a measure of central tendency. Similarly, geometrical mean is also the part of central tendency. Harmonic mean is also the part of central tendency. Why it is so? So please come on, say something, interact. This is a kind of interactive class, so you have to share your views. So I am also sharing the views. If you have different views, in that case, you may say something about the topic. So why all the measures are considered as a measure of central tendencies? This was my question. Yes, yes. Come on, say something about this. Because every time we are going to identify or find single value, median will give you idea about the single value, mode will give you idea about the single value, arithmetic mean will also give you idea about the single value, and harmonic mean will also give you idea about the single value. So all these single values will give you characteristics of entire population from where you collected the data through the instruments what you earlier developed, like schedule and questionnaire. So what is the meaning of schedule? Any one of you, please. Is there?
Hello.
Yes, yes, yes. Come on.
Sir, yes, sir. It is a means listing the datas which is
List.
getted from like from questionnaire or by any sources.
No, questionnaire and schedule are two instruments. Basically, there is no difference, but the way you are applying the collecting of data is different. How? If you want to collect data directly from your respondent, that is called schedule. That is called schedule. Okay, in questionnaire, what we do, we send the data through nowadays emails or through post to distant respondents to collect the information. Okay, so what is the basic difference? If you want to collect directly the response from your respondents, suppose if you have time constraint, in that case, it is highly impossible to collect the data through questionnaire. But if you have limited time, in that case, you need to utilize schedule. And there is advantages and disadvantage in both way of collection of data. In case of schedule, you can easily edit the data, directly edit the data. So basically, there are two types of edition. First one is live edition. Second one is field edition. So you can easily do live as well as field edition directly at the time of collecting data through schedule. But in case of questionnaire, it is highly impossible to edit the data. Okay, so in questionnaire, only central editing is possible, or live editing is possible. This is the basic difference. And there are other differences are also there, but this is the basic difference. Okay, so now come on to the main objective. Main objectives are, what are the main objectives of measures of central tendency? Obviously, to determine single value, as I said, to facilitate comparison when you have two or more sets of data, to facilitate statistical inference, so we can make conclusion at the time of testing hypothesis with the use of mean and standard deviation, and to help decision making process also. So this is also very useful as an objective to help decision making process. So now, next, what to next? So next is requisites of an ideal average. So anyone please say something about the requisites of an ideal average? Do you have any idea about that? Requisites of an ideal average. Come on. Be
Oh, sir,
interactive.
don't have
Yes.
idea.
Any one of you, if you have idea, but you are not saying anything. First, first one is it should be easy to understand and compute. Second is what? It should be based on all observations. It should not be unduly affected by extreme values. It should be rigidly defined by a mathematical formula. It should be capable of further mathematical treatment, or you can say algebraic treatment, so that its utility is enhanced. It should have sampling stability. It means that if one takes different samples from the same population, the average of any sample should approximately turn out to be the same as those of other samples. So these are the few ideal requisites of an, you can say, of an ideal average. These are the requisites. So these requisites are applicable throughout while writing or while explaining merits and demerits of all the measures like median, mode, harmonic mean, geometrical mean, arithmetic mean, etc., etc. So these are the, now this is the table. Are you able to understand the requisites of an ideal average? Because this is very important to understand all other measures of central tendency. Okay, come on, say something about this. Do you have any problem up to here? Hello.
No, sir.
Yes, come on, say something about that. So measures of central tendency, you see, mathematical average, positional average, and a spatial average. Okay. Arithmetic mean, popularly known as mean also. So simple and weighted. There are two types of arithmetic mean. One is simple, other one is weighted. Second one, geometrical mean. This is also simple and weighted. Harmonic mean, simple and weighted. Median, mode, moving average, and progressive average. So they are the part of forecasting, moving average, and progressive average. So moving average, sometimes called smoothing method. Okay, and progressive average, you might be knowing about the progressive average. So add cumulative value and divide it by number of observation, you will get the progressive average. So anyway, now come to the arithmetic. So what is the meaning of arithmetic mean? Any one of you please say something about the arithmetic mean. All of you might be knowing about the how to calculate the arithmetic mean.
Sir, it is
And
the average of all observations.
yes, you are correct. It is average of all observations. So just you add all the values, all the observations together and divide it by the number of observations. You will get the average. And this is only possible in case of discrete data. Okay. What about the continuous data? Or you can say this is possible only in case of unclassified data or ungrouped data. And when data is classified or grouped one or continuous one, in that case, how will you find the average? So there are different methods for finding of the average. First one is what? If it is when it is classified data. What is the first method? So that is direct method. Okay. That is direct method. What is direct method? Summation x bar equal to summation x by n, or if classified data, x bar is summation fx by n. I'm not going to explain and I'm not going to give you some numerical examples. Just I'm explaining how to find out the arithmetic mean. So these are the direct method, and here I included f. F is the frequency of the class interval. Okay, so just to find out the frequency, and if it is continuous data, it means classified data. In that case, mid value of the class interval you have to take out and multiply those, and n is nothing but the summation f, total number of frequency what you have in the given set of data. Okay, so these methods are called direct method. Other methods are also there, like deviation method, step deviation method, sometimes assumed mean method you can call shortcut method. They are the different methods statistician may call, or you may find in different books how to find out the arithmetic mean. After that, after finding out the arithmetic mean, so we discuss about the mathematical properties about the arithmetic mean. So are you able to read out this statement, any one of you? Any one of you? What is the meaning of this one? Summation x minus x bar equal to 0. How will you read? Yes. Summation of deviation taken from actual mean always be 0. Summation of deviation, this is the symbol of summation. Summation of deviation. Are you able to see what I am writing over here? Yes or no?
Yes, sir.
So summation of deviation taken from actual mean always be 0. And summation of deviation taken from other than actual mean never be 0. So you may consider one example. Say x equal to 1, 2, 3, 4, 5. Okay, so take out the average. Average will be 3. Okay, so x minus x bar, you may find out x means 1, 2, 3, 4, 5. You will get 0. So suppose you are taking some deviation other than 3. Okay, 3 is the mean value. So other than the 3, say 4. In that case, you never get the value of the 0. And it is also called point of balance. Why this one is called point of the balance? Because summation of all negative values and summation of all positive value will be, when we add these two together, we get the value of the 0. Therefore, it is called point of balance. And one more mathematical properties of arithmetic mean, and this property is very important because on the basis of this property, we can easily derive the formula of standard deviation, and this is also applied in case of deriving least square method at the time of forecasting by using normal equation methods. So how will you read? I have already read this one. So now you can Read this one. How will you read this? Come on. Try to say something about this. So, summation of a square deviation. So this is what? Summation of a square deviation taken from actual mean always be minimum. If it is not taken from actual mean, it will not be minimum. So these are the two important properties of arithmetic mean through which you can easily by using second property, you can easily derive the formula of standard deviation. Okay, and this is also utilized in case of least square method. So we'll discuss later about this later on. Okay, so what is the meaning of combined arithmetic mean? When you have two or more sets of data. So in that case, this can be manipulated. Set of data can be manipulated and ultimately you may get the value of the combined arithmetic mean. Okay, so this is one of the important property of arithmetic mean because it is capable of further mathematical treatment and algebraic treatment. So you have the knowledge of the combined arithmetic mean, how to find out the combined arithmetic mean. If you want to find out arithmetic mean, say when you have two sets of data, in that case n1 x1 bar plus n2 x2 bar divided by n1 plus n2. So this is the way of finding combined arithmetic mean when you have two sets of data. Suppose if you have more sets of data, in that case also you may find the combined arithmetic mean. So what is the meaning of n1? N1 is the total number of observation of set 1. x1 bar is the arithmetic mean of the set 1 or group 1. Similarly, n2 and x2 and n1 and n2 is the total number of observation in both sets of data. Likewise, you may easily calculate the combined arithmetic mean. Okay, therefore, it has the properties of what? It is capable of further algebraic or mathematical treatment. This is the reason why we mention as a property of arithmetic mean. Now, suppose there is one variable. If value of the variable increases or decreases by some constant, say c. So you have to add this value x plus c. Okay. So arithmetic mean will also increase or decrease by the same constant. Are you getting my point? When any one variable, because univariate analysis is here, if you want to increase this variable by some constant, say c or 2, 3, 4, 5, so arithmetic mean will also increase or decrease by the same amount. C may be 1, 2, 3, 4, 5, 6, anything. And when variable x multiplied by k, so arithmetic mean also multiplied by k also. And when it is divided by d, arithmetic mean also divided by d. Variable x means all the variables you need to consider, not one variable. Okay, so there are n number of variables and all are multiplied by k and all are divided by t. In that case, its arithmetic mean directly will give you the value of the arithmetic mean when you multiply by the k and divide it by d. So these are the few mathematical properties you need to remember for further analysis of univariate. So now we must understand about the limitations. You see, it is affected by extreme values. So what is the meaning of it is affected by extreme value? How arithmetic mean is affected by extreme value? So any one of you?
Sir, if there is an observation which is a large, which is an extreme value from
Yeah.
the other different observations.
Obviously. Suppose you are some negative value, 0 value, 1 lakhs value, negative 1 lakh value, positive 2 lakh value. After that, if you want to find out the arithmetic mean, so the value of the arithmetic mean will mislead you. Okay, so this is very, so answer was correct. Okay. It is not suitable for open-ended series. So what is the meaning of open-ended series? Suppose more than 0, less than 10. Okay. In case of classified data or in case of continuous data series, you may get such type of values. So more than 0, less than 10. Okay. So in such a situation, you can't find out the exact value of the arithmetic mean. It is also not affected. It is not suitable for U-shaped data distribution. In U-shaped, in lower value is something different, some higher values are there, and at the bottom, you may get some similar kind of values. In that case, you never get exact average value. Mean is also not suitable for qualitative phenomena. Okay, like beauty, honesty, intelligence. So what is suitable for this? Suitable for this is mean and mode. They are suitable for beauty, honesty, and intelligence. Okay, so we'll discuss at the time of discussing mean and mode. Okay, and mean does not lead a life of its own. What is the meaning of this? Mean does not lead a life of its own. Okay. What does it?
Sir, it means that it depends on other factors,
Like?
like all the values, sir.
You see, my dear student, dear researcher, dear colleagues, factor and variable is different. So here we are talking about the variable, not the factor. So how these two terms are different? Factor and variable. How they are different? What is variable and what is factor? Or both of them are same? Actually, factor is a linear combination of different variables. Okay. Sometimes at the time of factor analysis, we consider this linear combination as a variable. Factor may be considered as a variable when you have large set of data, say 500, 400, 300, 1000, 20,000. Okay, in that case, it is highly impossible to utilize all the variables together. In that case, what will you do? You have to reduce the data using factor analysis, and after reduction, so there are so many reduced data that is called factors, and you may consider all those factors as a variable. So this is the basic difference between variable and factors. So here, better you say variable. Okay. So mean does not lead a life of its own. So there is no sense of saying 3.6 or 2.6 children. Average number of children, 3.6. Average number of children, 2.5. So this is absurd. So therefore, you can say mean. There are so many examples you may quote. Mean does not lead a life of its own. It gives misleading conclusion in case of non-homogeneous data. So what is the meaning of homogeneous and non-homogeneous? What is the meaning of homogeneous, non-homogeneous? So this is simple, very simple. What is homogeneous?
Having some same characteristics.
Having some same characteristics. Suppose you are collecting data from a particular classroom because level of understanding, level of knowledge, both of them are same. So what you collect from that class, you will get similar kind of information. That is called homogeneous. Suppose you want to collect data from all the classes, say class 5 to 10, mix all those students. And when you ask about the question, you may get different answers. So that is quite, that is not a homogeneous data. You may call it as a heterogeneous data. And from mixed population, we can't get homogeneous data. Okay. So this is the meaning of homogeneous and heterogeneous. So what about the weighted average? Sometimes you have to give some weight for some work. Okay. Suppose if you want to pass a particular examination, so in examination there are so many subjects, so you need to give more weight for particular subject to pass the examination. So you have to give more weight, more attentions you need to give. Okay, so obviously when we consider simple average, in that case we may get some different answers. But if you provide some weights to particular subject, okay, in that case, you may understand the importance of the weighted average. Suppose you have certain set of data, okay, you have given some weights. So before giving certain weights, you need to find out mean. After giving the weight, you need to find out average weight. So if both the weights are same, x bar equal to x bar w means weighted, equal weights are assigned. You are going to assign all the variables equal weight. X bar greater than x bar w, it means smaller weights is assigned to the higher values and vice versa. And x bar less than x bar weighted, it means higher weight we are going to provide higher values and lower weight we are going to lower values. Okay, this is the meaning of weighted average. And what are the use of weighted average? Uses of weighted average. So in construction of index number, weighted average is utilized, and standardization of birth and death rate. So basic use of weighted average is construction of index number as well as standardized birth and death rates. After that, we'll go for the next measure. So this is median. So median is very, very simple. So what do you mean by median? I want to know something about the median because you know very well what is the median.
So it is the middle value of all the observations.
Middle of the all observation.
The central position. Sir, the central position is known as median.
Central position of is known as median. It's okay. Suppose if you have even number of data and odd number of data, in that case, how will you get the median? First of all, what will you do? First of all, you have to observe the data, what you have, and arrange them in ascending order as well as in descending order. Either you have to arrange in ascending order or in descending order. And this is applicable only in case of discrete data. This is not applicable in case of continuous data. Discrete data means ungrouped data, or continuous data means group data, or unclassified data or classified data. So if you have 1, 2, 3, 4, 5 observations, so this is odd or even? 1, 2, 3, 4, 5. This is
Odd.
even or
Odd, sir.
odd number of data. So in odd number of data, you can easily find out the middle value, 5. So this will give you idea about the position of the data in data set. Position of the data. Median means this will give you idea about the position of the data in the data set. Therefore, it is also called positional average. And sometimes it is also called partition value. Why this one is called partition value? Here, I have taken one example, 1, 3, 5, 7, 8. Suppose this is the data you have. Arrange, first of all, you have to arrange this in ascending order. So 5 means what? 5 is the position and partition. Okay. So first data, second data, third position. This is the third position. So this is also one of the formula through which you can get this position. So n plus 1. Okay. N plus 1 means 1, 2, 3, 4, 5. So 5 plus 1. Okay. 5 plus 1 divided by 2. This is the 6 by 2. So this is equal to third. This is the third position. So after arranging, you see, this is the first, this is the second, this is the third position. Therefore, this is called positional average. Position of the data on third place is what? 5. So 5 is the value of the median. But position is what? Third. Are you getting my point? So this is called median. Here, 50% of the data will lie left side and remaining 50% data will lie right side in case of median. What about the data set which have even number of observations? So in case of even number of observations, you may consider two middle values and take the average. Directly you will get the value of the median. But how will you get the position of the data in data set? For that, apply the same formula, n plus 1 by 2. So n equal to 1, 2, 3, 4, 5. So 6 plus 1 equal to 7 divided by 2. So this is equal to 3.5. So now there is no position of 3.5. This is the 5 has third position. What? 0.5. So 5 plus 0.5 means 1 by 2 into take this one, 7, 7 minus 5. Okay, so 5 plus 1 by 2 into 2. So this becomes 1. So ultimately this is 6. So this is 6. So ultimate value of the median is 6 when you are considering middle two values. And if you want to apply the concept of position of the data, so 3/5 position, with the use of this 3/5 position, you can easily get the value of the 6. So this is the exact value of the median. Are you able to understand this one? Hello? Is there any?
Hello, sir. Sir, I have a doubt.
Please.
In this, sir, 5 plus half.
You see, here we have how many observations? 1, 2, 3, 4, 5. 1, 2, 3, 4, 4, 5, 6. 6 number of observations.
Sir.
Okay. So this is the formula, n plus 1 by 2. So total number of observation is how much? 6. So 6 plus 1 equal to how much? 7 by 2. So 7 by 2 will give the value of 3.5th position. Okay. So where is the third position in the data set? After arranging in ascending order, fifth has third position. It's
In
okay?
between 5 and 7. Yes, sir.
After that, consider next value 7, 5 to 7. So what about the 0.5? So just you add 0.5 means half. Take the difference of succeeding number. So what is the succeeding number of 5? 7. 7 minus 5. Okay. So plus 1 by 2 into 7 minus 5 equal to 2. So this is equal to 1. Obviously, 5 is the number at third position, plus 1. So this is the value of 6. So in both the cases, you will get the value of median equal to 6. What is the position of the 6? Position of the 6 is 3.5th position. Are you able to understand this one?
Yes, sir.
Similarly, you see, suppose when we consider a line as a data set, suppose you are considering a line. Line is what? Line is a set of data, as you know, different set of points of data. Line is a set of points of data. So when we divide this into two equal parts, two equal halves, in that case, one perpendicular line required to divide entire set of data. If you want to divide this line into two equal parts, in that case, one vertical line is required. This divides entire set of data into two equal halves. 50% data will lie left side and remaining 50% data will lie right side. This is called median. Median means n by 2. Total number of data divided by 2. And what about the quartile? What is the meaning of quartile? What is the meaning of octile? What is the meaning of decile? And what is the meaning of percentile? They are also called positional average. They are also called positional average. In case of quartile, we are going to divide entire set of data into 4 equal parts. Okay, so 1, 2, 3, 4. So when you divide entire set of data into 4 equal parts, considering a line as a set of data, we need to divide it by 3 vertical lines. So 25% here, 25% here, 25% here, 25% here. But first quartile and third quartile. And what is second? What is the meaning of second quartile? Second quartile is nothing but the median. Second quartile is nothing but the median. So here we are going to consider only 50% of data for the analysis. Are you getting my point? This will lies in between Q1 and Q3. Similarly, When we talk about the octile, so obviously octile means n by what? N by
8.
8. So we need to divide entire set of data into 8 equal parts by drawing 7 lines, by drawing vertical 7 lines when we consider line as a data set. So this is called octile. So obviously O4 is also equal to what? Median. O4 means fourth octile is equal to median. Median equal to Q2 and O4. And here D5 in case of decile n by 10. Okay, so n by 10 is the decile. It means you need to divide entire set of data into 10 equal parts. Similarly, in case of percentile, we have to divide entire set of data into how many equal parts? 100 equal parts. So 99 vertical lines are required. So P50 is also equal to median. It means median equal to Q2, median equal to O4, octile 4, and median equal to decile 5th, and median equal to 50th percentile. Someone may ask me, what is the value of 8th octile? So can you say something about the 8th octile? Come on, say something. How will you get the value of 8th octile?
Sir, is it 0 or?
Beta, it is not possible. Is it possible? You see, here we have only first octile and 7th octile. There is no sense of saying 8th octile and 10th decile and 20th decile, 100 percentile. 100 percentile is a term you may get in the examination. So this is a relative term. But here we can't get the value of 8th octile or 10th decile or 4th quartile. So now you are able to understand different types of positional averages, and these averages might be helpful at the time of analyzing data in different types of research. Okay, so now come to the mathematical property of median. So when we consider summation of absolute value, absolute value taken from median should be minimum. This is the only property which it has. Now merits, it is useful in case of open-ended series, whereas arithmetic mean was not useful in open-ended series. It is not affected by extreme values because here we are not going to consider all the observations. Okay, in median we are not going to consider all the observations. So just we are going to consider middle value. Okay, it is most suitable average for dealing with qualitative data like beauty, attitude, preferences, etc., etc. And it minimizes the total absolute deviation. So these are the few properties, or you can say merits of, don't say properties, merits of median. After that, next one is limitation of median. So limitations everywhere is very important in analysis. Without having the knowledge of limitations of a particular measure, you can't utilize them properly. So you must know limitations of all the measures at the time of univariate analysis or bivariate analysis as well as multivariate analysis. So it requires, obviously it requires arrangement of data in ascending or descending order. Either you have to arrange ascending order or in descending order. Don't consider both the orders together So you have to consider only ascending order or descending order. Second one, it is not based on all observation, as I said. It is not capable of further algebraic treatment, obviously. Here we are not going to find the combined median. Okay. So it is affected by sampling fluctuations than the value of the mean. Obviously, it should not have sampling stability. Because of this reason only, at which journey has been performed or completed. And for the rates and ratios involving price and quantity, harmonic mean is used. So these are the two important uses of harmonic mean. You may apply harmonic mean at the time of applying or finding out these two. Now limitations are also there. So without understanding the limitations, you can't be able to apply other measures, including harmonic mean, correctly. So it can't be computed when one or more items are zero. It can't be computed. Understand, it can't be computed when one or more items are zero or one or more values are zero. It gives largest weight to smallest items. Hence, it is not useful for analyzing econometric data. So in economics, this is not widely used. Okay, so if you want to find out weighted harmonic mean, so this is the formula, summation y by summation w by x. Relationship among the averages. So when we have for a particular data set, for particular frequency distribution, value of arithmetic mean equal to geometrical mean equal to harmonic mean. So values of all items are identical. Okay, then only we can get value of arithmetic mean, harmonic mean, and geometrical mean equal. If harmonic arithmetic mean is greater than geometrical mean, greater than harmonic mean, so items are not identical. So these are the few, and one more relationship is also there. So geometrical mean is the, you might be knowing, those who have studied in class 12, GM equal to under root arithmetic mean into harmonic mean. This is also very important relationship through which you may convert or you may find other values when two values are given. Now come to the how to select the suitable measure, suitable average. This is very important because after having studied this much of information about the different measures of central tendency, we must know where to apply which measure. Okay. So when to give equal importance to all the items of a series, in that case, to give equal importance to all the items of a particular series, so arithmetic mean is suitable. To locate position of an item in relation to other items, so here we need to apply median and other positional averages. Positional averages, sometimes also called what? Partitions value. Okay, so remember all these things. So entire set of data can be partitioned in different segments, which carries certain percentage of data. Sometimes it carries 50%, sometimes it carries 25%, sometimes it carries 12.5%, etc., etc. To give more importance to small items, okay, than big items. Okay, so I have written twice. So I want to start this one. To give more importance to small items than big items. So in that case, geometrical mean is applied. To give greatest importance to small items, harmonic mean is suitable. And this is, earlier one was based on purpose. Okay, now it is based on nature and form of the data. So for open-ended distribution, J-shaped or reverse J-shaped distribution, as for example, price distribution and income distribution, in that case, you have to apply median to describe qualitative data like consumer preference. In that case, apply mode to compute average rates of increase, decrease, average ratios, average percentages. In that case, apply geometrical mean to compare the values of a variable with another variable which is constant, varying speed with constant distance, varying quantitative quantities bought or sold per rupees, harmonic mean. And in all other cases, you have to apply what? Arithmetic mean. So these are the different nature and purposes. On the basis of that you may select suitable measure of average. Okay. Next one is moving average. So moving average, here we are not going to consider all the data set. So this is applicable only in case of time series. Okay. Time series means historical data taken at equal time intervals. So you might be knowing about the time series. What is the meaning of time series? Any one of you, please. What is the meaning of time series? No idea. Time series data means historical data collected at equal time intervals. Time interval may be fraction of second, millisecond, nanosecond, year, decade, fortnightly, you may consider. So generally, smoothing average method is also called moving average method. Other smoothing method are also there, like exponential smoothing method, adjusted smoothing method. Okay, so there are other methods, but here this is the part of the average. Therefore, I discussed about this. Here we do not consider all the values of the data. And what is the meaning of progressive average? So find out the cumulative sum. So if you have 2 years of data, 3 years of data, 4 sets of data, so divide it by 2, 3, 4 accordingly. That is called progressive average. Now, second important measure of variation. Measure of variation is also called average of second order. So measure of dispersion, average of second order, this is also called measure of variation. Actually, what is the meaning of variation and dispersion? Deviation from what? In general sense, what do you understand by variation? I'm not asking exact. Right now, I'm not going to ask exact definition of variation. Just I'm asking about the deviation. What is the meaning of deviation?
So variation means some changes. The difference.
If you are not getting actual value. So this is the difference of variation, means difference between actual and realized value. If there is difference between actual and realized value, that is called what? Deviation. and deviation is nothing but the variation, and variation is also the one of the important measure of risk. Those who are from finance background, variance, standard deviation, these are the measures of the risk. Okay, so now here variations measure the extent to which the item vary from some central value. So what is here? We have central value. Central value, mean is the central value. Okay, so when we take the deviation from the mean, so you may get the deviation, that is nothing but the variation. And what is the significance of measures of dispersion or measures of variation? So these are the few significance. Sorry. To determine the reliability, with the help of reliability, you can easily find out you can easily determine the reliability of the data. What we have to facilitate comparison, to facilitate control, and to facilitate the use of the other statistical measures. This is also helpful in finding out regression lines, coefficient of correlation, etc., etc. So now we'll move to next slide. So it carries all the qualities of good measures of an average. When we talk about the properties of measures of variation, so it carries all the qualities of good average of good measure of average. So are you able to repeat the properties of or qualities of good measure of an average? Are you able? Come on. So so now I am going to give you some break. Okay. So take the break of how many minutes? 15 minutes? That is sufficient to you? Hello? Hello?
Sir,
Yes, sir.
Okay. So you have to take 15-minute breaks. After that, we'll continue from here only.
okay, sir.
Okay.
There's a session break of 15 minutes. The session will start again after 15 minutes.
Hello.
Yes, you're audible.
Okay. Slide is visible.
Yes, yes.
So now I am going to start second half. So please say something about all the qualities of a good measure of an average. Come on. Say something, please. don't have any idea? Say yes or no. What are the ideal properties of an average? No idea. This is very simple. Once again, I would like to repeat this. Simple to understand, easy to calculate, rigidly defined, based on all items, capable of further algebraic treatment, sampling stability, not unduly affected by extreme values. These are the few ideal properties of an average that is also applicable to variations or measures of dispersion. So now, common over here, absolute measures of dispersion. So this is based on selected items, and this is based on all items. When we consider only selected items, so range, interquartile range, okay, and based on all items, mean deviation and standard deviation. So these are the absolute measures. When we talk about the relative measures, so obviously their coefficients are the relative measures. As for example, coefficient of range, coefficient of interquartile range, coefficient of mean deviation, coefficient of standard deviation. These are the measures of what? Relative, or you can say these are the relative measures. Okay, so on to the next. Range. What is range? All of you might be knowing. What is range?
Difference between highest and lowest values in the given data.
Yes, you are perfectly correct. Difference between highest value or lowest value. So range is also one of the measure of variation. So this difference will give you idea about the variation of highest value or and low, in between highest value and lowest value. So now, how will you utilize the concept of range? Actually, it facilitates statistical quality. You might have heard the term of statistical quality control. So you might have heard the name of P chart, R chart, etc., range chart. So that is also one of the techniques to control the quality statistically. It facilitates the weather forecast. Okay, so you may find out the range of few historical data or few data through which you can easily identify forecast of the weather. It is used to calculate variations in the price of shares, debentures, bonds, etc. Suppose if I want to know the standard deviation of two values, say 5 and 3. So what would be the standard deviation of these two values? With the use of range, you can easily find out the standard deviation of two values, say 5 and 3. Okay. So these are the two numbers, 5 and 3. Someone may ask you, find the standard in competitive examination, in any test, find out the standard deviation. So what is the value of standard deviation? So it's a standard deviation equal to range divided by 2. And this formula is applicable only when you have two values. This is not applicable in case of three values or more values. This is applicable only in case of two values. So what is the range here? Tell me. What is the range? 5 minus 3, 2 divided by 2. So 2 divided by 2. So what is the value of standard deviation? Value of standard deviation is 1. It's okay? It's okay or not? Hello?
Yes, sir.
If you have only two values and someone may ask you, find out the standard deviation of these two values. So just you take the difference and divide it by 2, that the value what you get, that becomes the value of the standard deviation. So this is very simple to find standard deviation, or else you may apply the standard formula for finding out the standard deviation. No problem. So what is limitation? What are the limitations of the range? It is not possible to find out range in case of what? Open-ended frequency distribution. In case of open-ended frequency distribution, we can't identify highest value as well as lowest value. Without knowing the highest value and lowest value, we can't get the value of the range. So this is the major limitation of range. Okay, and this is also one of the use of range. When you have two values available, directly you can find out the value of the standard deviation. Quartile deviation can be used in open-ended series. Why quartile deviation can be used in open-ended series or frequency distribution? Are you able to share some idea about this? Quartile deviation can be used in open-ended series. Why? Why this can be used? Come on. No idea. Actually, in quartile deviation, we consider only middle 50% of the data. We can't consider entire set of data. Therefore, quartile deviation can be used in open-ended series because here we have middle 50% data available. It's okay? It's okay or not? Nobody is interacting.
Yes, sir.
So now, standard deviation. This is very popular term. Everybody knows. I don't want to explain this term right now, but these are the few properties we need to explain. It is independent of origin but not scale. What do you know by this? It is independent of origin but not scale. कोई बता सकता है क्या? बोलिए बोलिए. It is independent of origin but not scale. What does it mean? किसी को नहीं पता है कोच? You know nothing about this. Suppose the value of standard deviation increased by some constant, say k. It means other variables will also be increased by k, or you can say other variables, when other variables increased by k, obviously the standard deviation of those variables will also be increased or decreased by k. But when all the variables divided by or multiplied by certain constant, in that case, standard deviation will not be divided by or multiplied by certain value. That is the meaning of but not scale. This is the meaning. Okay? Are you able to understand this? बोलो हाँ या ना?
Yes, sir.
Okay. It has fixed area relationship. It has fixed area relationship. So you might have seen these terms: x bar plus minus 1 sigma, x bar plus minus 2 sigma, x bar plus minus 3 sigma. So if you draw this diagram, like this. This is x bar. So here and here. This side negative, left side negative. So x bar minus 1 sigma. Here x bar plus 1 sigma. Likewise, this will increase in either direction. 2 sigma and 3 sigma. Okay, so are you able to understand what is the range of this distribution? What would be the range? So maximum is 3 sigma either side. So plus 3 sigma this side and minus 3 sigma left side. So I am asking about the range. The range is what? Range equal to highest value minus lowest value, as you said right now. So highest value is 3 sigma plus minus 3 sigma. So this is what? 6 sigma. And this 6 sigma technique is very important in quality control. And this term is derived from here because entire distribution, entire dispersion of data will lie in between minus 3 sigma to plus 3 sigma. This is the underlying concept of this. It has fixed area relationship. Now, I'm going to ask x bar plus minus 1 sigma. So what is the percentage in between x bar 1 plus minus 1 sigma? How much percentage of data will lie? So 68.27% of data, 27% of the data will lie in between x bar plus minus. It means from here to here, 68.27%. What about this? X bar plus minus 2 sigma. So 95.45% of data will lie. What about this? X bar plus minus 3 sigma. So here 99 point, how much? 99.73% of data will lie. It means this is approximately 100%. So entire dispersion has range of what? 6 sigma. And this is the technique for identifying and limiting the quality at the time of manufacturing for different manufacturing processes. So this is the meaning of this. Now, what about this one? So you see, standard deviation is less than quartile deviation or mean deviation? No. Standard deviation never be less than quartile deviation and what? Mean deviation. This is always greater than quartile deviation and this one, mean deviation. And there is one rule through which you can remember this formula. So quartile deviation and standard deviation, this is the formula or relationship between quartile deviation and standard deviation, quartile deviation, mean deviation and this one, standard deviation. So this rule is called 2, 3, 4, 5 rule. This is called what? 2, 3, 4, 5 rule. So that you can easily remember. So 2, 3, 4, 5 rule means quartile deviation equal to 2 by 3 sigma. Sigma means standard deviation. Mean deviation equal to 4 by 5 sigma. So you can easily find out the value of quartile deviation as well as mean deviation when you have the value of standard deviation given or available. So when you have the value of standard deviation available, you can easily find out the quartile deviation and mean deviation. Obviously, by seeing these two formula, you can easily say standard deviation never be less than quartile deviation or mean deviation. And one more property is, as I explained in dealing with arithmetic mean. So a square deviation taken from actual mean always be minimum. So this is the basis for deriving the formula of what? Standard deviation. So what is the popular formula of standard deviation? Summation x minus x bar whole square divided by n under root. So this is the formula. You might have seen and you might be knowing about this formula. And this is the basis of this one, deriving this or stating this formula. Okay. Now standard deviation of, suppose n natural numbers are given. Suppose someone may ask you, find out the standard deviation of 1 to 100 items. So 1 by 12 n square minus 1 will give you directly the value of the standard deviation of n natural numbers. This is also important to find out standard deviation directly or quickly, and this is very useful in the competitive examination. So 1 by 12 n square minus 1 will give you idea about find out the standard deviation of n natural numbers. And obviously, it has the properties of further algebraic treatment. So combined standard deviation, you can get it by formula, by this formula, n1 sigma 1 square into n1 means number of observation of set 1, sigma 1 is the standard deviation of set 1. Similarly, n2, n3, n1, d1. What is the d1? d1 is the difference between mean of the first group and combined mean of the set of two sets of data. Here I am going to consider only two sets of data. You may consider n sets of data, 3 sets of data, 4 sets of data. These are the explanation of all the properties of standard deviation. Next, interpretation of coefficient of variation. You see, a percentage of coefficient of variation. So what is the meaning of coefficient of variation? Suppose if you want to find out mathematically CV equal to sigma divided by x bar into 100. This is the coefficient of variation in terms of percentage. Okay. And when we talk about the sigma by x bar, so this is coefficient of standard deviation. And this is coefficient of variation. So lower the value of coefficient of variation, group is more consistent, uniform, stable, and homogeneous. When you have lower coefficient of variation, and when you are comparing 2 or 3 sets of data, okay, in that case, a group of data which has lower percentage of coefficient of variation is more consistent, more uniform, more stable, and more homogeneous. And vice versa, if it is higher, so is less consistent, less uniform, less stable, and less homogeneous. So after that, this is variance. Variance means square of the standard deviation. Square of the standard deviation will give you the value of variance directly. So a smaller value of coefficient of, this is variance. Okay, smaller value of variance will give you idea about the lesser the variability or greater uniformity in population, and larger the value of variance, greater the variability or lesser uniformity in the population. By using these concepts, you can easily find out whether data is consistent, uniform, stable, homogeneous. Okay, so now come to the next slide. You see, I'm not going to discuss in detail skewness. Skewness is directly or indirectly related with the symmetry of the frequency distribution, whether data is symmetrical or asymmetrical. So it refers to lack of symmetry in the shape of frequency distribution. Its measures show direction and extent of skewness. So you might have heard the term in earlier discussion of this topic, positively skewed, negatively skewed, okay, symmetrical. And kurtosis is also one of the term, refers to degree of flattedness on the or pickedness in frequency distribution in relation to normal distribution. Actually, this platykurty comes from the name of platypus. It's actually, this is the shape of the platypus. This is the tail. And this is the, so this is the animal platypus. So platykurtic comes from here. Okay. Leptokurtic means when two kangaroos are fighting. So this is called leptokurtic. Lipping. Okay. So these two terms derived from this one. And mesocortic. In between leptocortic and platycortic, there is a mesocortic. So next class slide, I am going to show you. You see, this is similar to kangaroos. They are fighting for their rights. So now this is leptocortic and this is platycortic. Platycortic, this is similar to platypus, and this is the in between mesocortic. So a spread of base is larger, wider in case of platycortic. So this is the dispersion and this is the variation. Whereas in case of leptocortic, this is the minimum, and in case of mesocortic, this is in between. So this is how you can identify the flatedness or pickedness of the symmetry. So now I'm coming to next slide. Now I want to start bivariate. So every individuals will have single units. Every individual of single units will have 2 or 3 things. When we consider individual, an individual you can say. So every individual will have height and weight. So we find the relationship between these two variables, whether height and weight are related or not, and how they related. What is the degree of relationship? What is the direction of relationship? So that can be studied under correlation. And here obviously in bivariate, here we are going to study 2 variables. Okay, so one is dependent variable, otherwise independent variable. That will be discussed in regression also. In regression means what? Regression means actual meaning of regress means going back, suppress. Same concept is utilized for forecasting concept in another way. Actually, regression means suppressed or going back. So height and weight. So few examples I am going to cite over here. Height and weights for correlation, rainfall and the yield of the crop. This is also one of the example, whether they are positively related, negatively related. It depends. Age of husband, age of wife, dose of insulin and blood sugar, age of individual and their blood pressure, and advertisement expenditure and sales. So you can easily establish under correlation degree and direction of the relationship of 2 variables. Okay, therefore it is called bivariate. Here also these 2 variables, one of them is called dependent variable, and dependent variable is also called explained variable, and independent variable or explainable variable. So all independent variables are manipulated and their effect is studied on dependent variable in case of regression. So this will give you idea about the nature and extent of average of 2 variables. Okay, so this is the meaning of regression. Now next, correlation analysis. Actually, correlation analysis is a type of statistical tool or technique used to measure degree and direction of relationship, as I said earlier, between the variables. When we have 2 variables, so first of all, what will you do? First of all, you have to establish whether both variables are related or not. If they are related, what is the degree of relationship? What is the direction of relationship? And finally, we calculate cause and effect of relationship. So every time we can't able to find cause and effect of relationship, and that will be studied under regression. So now I'm going to explain some usage of correlation. Actually, these are the uses. In earlier years, concept of correlation analysis widely used in economics. So economic theory and business studies show relationship between variables like price and quantity demanded, advertising expenditure and sales promotion measures, etc. Other variable nowadays it is applicable in almost all area of management or also all everywhere in social sciences, everywhere in science also, biological science also. Now, second use of this prediction based on correlation analysis will be more reliable and near to reliability. Near to reality. Suppose variables are related, you identified at the time of doing correlation analysis, you can easily predict considering one of the variable as a dependent variable, other variable is independent variable, because already both of them have correlated value, and prediction will be accurate. So come to the next. Next is correlation analysis contributes to the understanding of econometric behavior. Further, it helps in developing econometric models. There are so many econometric models in economics based on certain assumptions where we apply the concept of correlation and regression at the time of developing all those models. And obviously, those models will be applied for predicting some important things. And that is also applicable at the time of making 5-year plan of Indian economy or 5-year plan of the country. Now the measure of coefficient of correlation is a relative measure of change. It is relative measure of change. Okay, so whether they are correlated or not, if you change one variable, other may change, and if you change other may also change. So what is correlation analysis? Correlation analysis is the analysis of studying the relationship between two variables, and these relationship can be measured in regression analysis on the basis of considering one of the variable is dependent and other one is independent. So independent variable can be manipulated and their effect is studied on dependent variable. So now come to the point, types of correlation. What are different types of correlation? Here we have, so negative correlation, positive correlation, simple correlation, multiple correlation, okay, total multiple correlation. Next one is linear correlation, non-linear correlation, partial multiple correlation. So what is the meaning of positive correlation and what is the meaning of negative correlation? So you might have some idea about that. So what is positive or negative correlation? What is positive, what is negative correlation?
So positive correlation would be when both the things move in the same direction.
Yeah,
Like
so,
if the price increases, the demand will also increase. And negative for a product. And negative correlation would be for a product. If the price increases, the demand would decrease.
so this is the one example. There are so many other examples you may consider. Okay. So when both the variables vary in opposite direction, the correlation is said to be what? Negative. If they are moving in same direction, as you said, that is called positive correlation. So now, what is the meaning of simple correlation? In simple correlation, only two variables are studied. Okay. As for example, relationship between yield of wheat per acre and the amount of rainfall. And this is what? This is a problem of, or this is a kind of simple correlation. What is the meaning of multiple correlation? Here we study between or among, you can say, among three or more variables, whether they are related or not. If they are related, that becomes multiple correlation. As for example, I am considering a real example. Wheat per acre, amount of rainfall, and amount of fertilizers. Okay, so here we have how many variables? Three variables. And we need to know whether they are related or not. That is called multiple correlation. When we study correlation among three or more variables, then we call it multiple correlation. And what about the partial, multiple, and total multiple correlation? So what is the meaning of multiple correlation? In case of multiple correlation, one may study three or more variables, but considers only two variables to be influencing each other, and the effect of other influencing variable being held constant. This is the meaning of partial correlation. What about the total multiple correlation? In case of total multiple correlation, one studies three or more variables without excluding the effect of any variable held as constant. Obviously, linear correlation is very simple. When we draw a diagram, whether they are linearly related or non-linearly related, that can be easily seen on the graph sheet. Okay, so this is all about types of relationship. Next one is what? Next one is method of studying correlation. So obviously, there are two basic methods. First one, graphic method. So popularly known as scatter diagram or algebraic method or a mathematical method, Karl Pearson coefficient of correlation, and rank method. These are the two famous methods through which you can easily find out the degree and direction of the correlation. Next one, coefficient of correlation. Few of the formulas I am going to given you for finding out the coefficient of correlation. R equal to covariance of x and y. Here we have two variables. And sigma x means standard deviation about x and standard deviation of about y. So what is the meaning of covariation? Sometimes correlation is also considered as a covariation. So what is the difference between correlation and covariance? Covariation. Do you have any idea about that? Yes? Say something about this. Covariation and correlation. In case of covariation, two variables are moving together, either in positive direction or in negative direction. Okay. But their value of covariation lies in between minus infinity and plus infinity. Whereas in case of coefficient of correlation, it lies between -1 to +1. This is the basic difference and major difference between covariation and correlation. Will you be able to understand this one? Hello?
So please explain again.
You see, covariations means obviously two variables are moving together. Okay. In correlation also, they are moving towards rising. But when we find out the value of covariation, so what is the formula for covariation? This is actually x minus x bar, y minus y bar, divided by n. This is the meaning of covariation. And this is the meaning of correlation. Okay. So if you find covariation, its values lies in between minus infinity to plus infinity. Whereas in case of R, it will lies minus 1 to plus 1. This is the basic difference between these two, because their formulas are also different. They have different formula to get the values. So this is the basic difference between covariance and correlation. But sometimes they are considered as same. Sometimes, not always. And the sigma x and sigma y, as I explained, sigma x means, suppose if you want to find out sigma x, so obviously summation x minus x bar whole square divided by n under root. Similarly, sigma y equal to summation y minus y bar divided by n under root. So these are the ultimately we'll get this relationship. So this is not exactly x and y. X means x minus x bar. Y means y minus y bar. Suppose you know this formula. After knowing this formula, you have written the same formula and got the answer of coefficient of correlation by using this formula. You never get correct value, because the value of x is x minus x bar, deviation taken from the actual mean, and y is also deviation taken from y minus y bar. This formula is simplified only to remember this formula. Okay, so don't confuse with this formula. R equal to x y under root summation x square summation y square. Here the value of the x equal to x minus bar and y minus y bar. So this is all about covariation and correlation. Now you are able to understand? Hello.
Yes, sir.
So now properties of R. Once again, as I explained, what is the meaning of independent of choice of origin, independent of choice of scale? So it has this coefficient of correlation will have, and it has these two properties. And the next slide, I'm going to discuss with other properties. Independent of units of measurement. Independent of units of measurement. Why it is so?
Maybe because we are just seeing the direction of change.
No, right now I told you we can easily find out the relationship between height and weight. Height is measured in terms of centimeter, feet, millimeter, meter, etc. But weight is measured in pounds, kg. So these are the two different units. Are you getting my point? And by the use of two different units, we can easily establish whether values are correlated or not correlated. So this is what? This is independent of units of measurement. It's okay or not?
Yes, sir.
Yes, this is the meaning of this. Now R lies, as I said, R lies in between -1 and +1. So -1 is also considered as a perfectly negative correlation and perfectly positive. So we'll discuss next. Now R is the geometrical mean of two regressions coefficient. So in regression, we study line, straight lines. So there are two types of lines. One is y on x, another one is x on y. So what is the meaning of x on y? This is x and there is a perpendicular line, y. So this is y on x. Y perpendicular x is called y on x. And x perpendicular y is called x on y. Are you getting my point? So a straight line, here we have two types. One is y on x, other one is x on y. That will be discussed in detail at the time of discussion regression. So here Vxy means this is regression coefficient x on y and regression coefficient y on x. So coefficient of correlation is the geometrical mean of two regression coefficients. Coefficient of correlation is the geometrical mean of two regression coefficients. So that is expressed like this. And by the use of these two regression coefficients, you can easily establish the coefficient value of the coefficient of correlation. So in case of correlation, you need to find out the value of Vxy and Vyx. After that, multiply and take the under root of these two, you will get the value of the R. So now I'm going to give you some interpretation about the R. R lies between -1 and +1. So what is the meaning of R +1? If the value of the R after finding +1, so this is perfectly positive correlation. If it is -1, perfectly negative correlation. If it is 0, no relationship. If it is, its value lies in between 0.75 +1. So this is high degree positive correlation. This is called what? High degree positive correlation. If it lies -0.75 to -1, so this is called high degree negative correlation. So this is a kind of thumb rule through which you can easily identify whether relationships are positive, perfectly positive, negative, perfectly negative, and no relationship on the basis of value 1. Next one, you see, if R lies in between +0.50 to 0.75, so this is moderate degree of positive correlation. And if it lies -0.5 to -0.75, this is moderate degree of negative correlation. And R is less than +0.5, low degree positive correlation. If it is greater than -0.5, low degree negative correlations. So these are the values through which you can easily identify direction of the relationship. And degree already you have. Value is nothing but the degree, but negative positive is what? Direction. So both can be easily identified with the help of the value of coefficient of correlation. So some of the assumptions are also there. So without assumption, we can't develop a model. Empirical formula is nothing but a type of model, mathematical model. developed by researchers or developed by some statisticians. So now here we have some assumptions, because assumptions sometimes also considered as a limitations. So linear relationship between the variables. Two variables will have linear relationship. This is one of the assumptions, important assumptions. If it is not, correlation, coefficient of correlation can't be correctly determined, and it will give you the value of cause and effect relationship. And obviously data should be normal. In case of non-normal data, you can't find the value of the coefficient of correlation. Okay, so these are the three major assumptions of what? Correlation. Next one. What about the merits of coefficient of correlation? As you know, it gives direction and degree of relationship. So many times I repeated this line. It helps in estimating the value of the dependent variable from the known value of independent. So that will be discussed further also at the time of discussing regression, because regression is very important for bivariate analysis and correlation, and without studying correlation, you can't study regression. They are not mutually exclusive. They are not independent event. They are dependent event. Okay. Now here we have limitations. Some of the limitations are also there. Assumptions of linear relationship may or may not always hold true. Okay. So if it is not true, in that case, what do you do? In that case, you need to go for Z transformation for getting condition normal. Then only you can apply the concept of correlation as and regression. Z transformation is very important for making entire data set normal. Okay, now obviously it is time consuming, affected by extreme values also. It is affected by extreme values. So now you are able to understand these limitations without any problem. Now next one. Next slide is this. Requires careful interpretation. Obviously, it requires careful interpretation. So already I have given you table for the interpretation on the basis of values of coefficient of correlation. So there is another method, that is Spearman's rank correlation method. First one is Karl Pearson method. Second one is Spearman's rank correlation. So here we apply these two formula, R equal to 1 minus 6 and D square. D, where D is the difference between the ranks of two data sets or two observations. So where D equal to R1 minus R2. Okay. So this is the difference. Square, obviously this should be positive. And this is the formula. N is the number of observations. And if this formula is applicable only in case where there is no tie. If there is tie in ranks, if there is no tie in ranks, in that case this formula is applied. If there is tie in ranks, sometimes we may find difficulties at the time for finding coefficient of rank correlation. So for that, we have to apply some additive factors, and you may call it as a correction factor. So M and M. So M1, you consider this one as a M1 and M. M1 means number of item repeated first in data set. If it is M2, number of items repeated in second times. So different number of items will be repeated in data sets. Accordingly, you have to consider M. So first time, suppose three numbers are same, that is M, the value of them. Second time, 2 data sets, so M2 equal to 2. Third time, 4, or again 3. So likewise, you have to consider 1 correction factor, or 2 correction, or 3 correction, and more corrections, depending upon the number of repeated items in data set for finding out rank correlation. So this is 1 minus 6 summation d square m1 cube minus m1, similarly m2 cube minus m2 divided by 12 and so on. So these are the important formula for finding out the rank correlation. Now, next, what are the merits of this? So you see, simple to understand and easy to apply, because you might have observed the formula. That is very easy. Suitable for qualitative data, suitable for abnormal data also. Only method of ranks. So if ranks are not given, so it is not possible to find out the coefficient of correlation. If ranks are not given, in that case, what will you do? If it is possible, you need to find out the ranks. Okay. Depending upon the rank and depending upon the correction factor, if it is tied, you may find the value of the rank correlation. Applicable even for actual data. This is applicable also for actual data also. Okay. And what are the limitations? This is unsuitable for group data. If you have classified data, if you have group data or continuous data, in that case, this is unsuitable to find the value of the rank. Obviously, if there is tie between the ranks, in that case, it becomes tedious to calculate. And ultimately, this will give you not exact value, this will give you exact approximated value. Okay. Next, when to use rank method. This is also very important, because without knowing where to apply this method, we can't apply properly. So you must know when to use rank method. Rank method means Spearman rank correlation coefficient method. So number one, number of pairs of observation is not more than 30. If it is more than 30, in that case, it is highly impossible to apply to get the value of the rank. It means you have to take number of pairs of observation less than 30 or 30. The original data in the form of ranks. So original data must be in terms of ranks. So these are the conditions under which you may apply the rank correlation coefficient method. When rank correlation, where is rank correlation coefficient referred to Karl-Pearson coefficient of correlation. So if you want to find out Karl coefficient of correlation with the use of method of rank correlation, in that case, what will you do? If your data set, two data set have no repeated items, no repeated observation. In that case, up to 20 number of observations, both the methods will give you the same value. Number one. And number two, distribution is not normal. The behavior of distribution is not known. Only qualitative data, ranks are given and not the actual data. Okay, so these are the conditions under which you may prefer rank correlation. Now regression analysis. This is the last portion of our discussion. So it is a kind of statistical tool to study the nature and extent of functional relationship between two and more variables and to estimate or predict the unknown values of dependent variables from the known values of the independent variables. Mind it, the unknown values of dependent variable, which is also called explained variable, from unknown values of independent variable, that is also called explainable variable. One of them is called predictor and other one is called criterion variable also. Distinction between correlation and regression you must know, then only you can easily understand how to apply and where to apply correlation and regression and when to apply. So now, correlation and regression. So this is very simple. It measures degree and direction of relationship, as I repeated so many times in the discussion. It measures nature and extent of average relationship. Obviously, correlation is a relative measure. It is an absolute measure. And coefficient of correlation is independent of both origin and scale, as I explained in a real discussion. It is independent of change of origin, not scale. It is independent of change of origin, not scale. Now, fourth one, it is independent of units of movement, units of measurement, not movement. It is independent of units of measurement. Obviously, it is not independent of units of measurement. So, while applying regression, you need to keep units same of dependent as well as independent variable. And it is a correlation is not a forecasting device, and regression obviously is a forecasting device, because by using forecasting we can easily predict the future demand, and demand is the first step of any production system. Next, there may be there may be nonsense correlation. There is nothing like nonsense regression. What is the meaning of nonsense correlation? Like weight of a girl and income of a boy. Relationship between patient and hospital. Relationship between passenger and train. These are nonsense correlation or illusory relationship, where we can't apply concept of correlation. Are you able to understand this? What is the meaning of nonsense correlation? What is the meaning of nonsense correlation? Hello? Hello?
So that means both the things are unrelated.
Unrelated, yes.
Also
As for example, weight of a girl and income of a boy. They are not related. And passenger and train, okay, no relationship. And patients and hospital, actually they are also not related. So such type of relationship called illusory means false and nonsense relationship. Here we can't apply the concept of correlation. Okay, but whereas in case of regression, there is nothing like nonsense regression. So here we may apply the concept of regression. So these are the basic difference between correlation and regression. Some of the regression models or lines are here. So now there are two types of lines, as you know. You might be knowing, those who have studied +2 level in coordinate geometry. There are two lines, x on y. This is the equation of a straight line, y on x. So what is A and B? What is the meaning of A and B?
Sir, is it variable?
These are the constants. A and B are the constants. But in first case, this is called x-intercept. A is called x-intercept. In second case, it is called y-intercept. And B is nothing but the slope. So if you want to know the concept of A and B, suppose this is a line, okay, straight line. This is x and this is y. So this is y on x and this one is the origin. There will be one and only one origin in any graph. And this is what? Y equal to a plus bx. And this line, straight line, is intersecting on y-axis. So this is the point where it is, where it has intersected, and this is the A. The distance from origin is called A, and A is nothing but the y-intercept. Okay, and what is this? This is slope. B is the slope. Okay, this is B. B means change in y divided by change in x. So how will you get? So just you drop the perpendicular from here to here, and from here to here, you will get change in y. And from here to here to here, you will get a change in x. So this is nothing but the slope. Slope will give you idea about the percentage increase or decrease of production, sales, etc., etc., as per the question. So this is the meaning of y a plus bx, y on x. And similar fashion, similar way, you can explain this is x equal to a plus by. So a is, in case of this, a is x-intercept, b is the slope. And these are the two variables. One is dependent variable. So this one is dependent variable. Okay. And this is also called predictor. This is also called explained variable. This is explainable variable. And these are the criterion variable. Why? Why is the criterion variable? So one is dependent, other one is independent. So this is how you can set the two normal lines by using the concept of summation y minus yc whole square equal to minimum. So y means variable, yc means y calculated. So this is a plus bx whole square summation equal to, keep this is equal to 0, and differentiate by taking a differentiate partially. You may get two different equations, and after solving you may get these two normal equations. I am not going to teach you how to partially differentiate. Most of you might be knowing, you may not be knowing, but this is important. Summation x, I have considered this one, x on y summation x equal to n is the number of observation a plus b summation y, and summation xy equal to a summation y plus b summation y square. By using these two equations, you can easily set the value of a, get the value of a and b. Once you get the value of a and b, put these values here in the final equation a and b, and you can easily predict the value of the items in particular year. So here we need to consider some historical data under time series, and only we can get the value of projected value of x or y. So after this is another way of expressing line x minus, this is deviation method, x minus x bar equal to by